For day 10 notes, talking about absolute value functions. And these are just V-shaped graphs that can either open up or open down. So we're going to put in here V-shaped. A translation is a shift or glide of a graph horizontally, vertically, or both. For example 1, we have this V-shaped graph, and that is this here, okay? And so we want to know what's different about it over here. And if you notice, this right here is called the vertex, and you can see it's been shifted down 2 units. But the other part of the graph remains the same, and if you look here at these different locations, we go up 1 over 1, up 1 over 1, up 1 over 1. And then we're going to go up 1, left 1, up 1, left 1, up 1, left 1. And so it creates this V-shaped graph. This part of the graph is exactly the same. It's just the vertex has moved or shifted down. So how do the graphs relate? We can say same V-shape, but shifted 2 units down. Okay, so now the question is, how do we draw these V-shaped graphs? So for example 2, it says graphing a vertical translation. If you notice, this positive 2 is outside of the absolute value. It's not in here. So if it's on the outside, that means that we will go to that positive 2 on the y-axis. And we will put a point there. Okay. Then, to graph our V, you are going to rise 1 and run 1. And you're going to do that 3 or 4 times. So rise 1, run 1, rise 1, run 1. That gives you a nice length there. But then you're going to go up 1, left 1, because a V shape has to be symmetric. So like what is on this side should have a matching side here, matching point. So up 1, left 1, up 1, left 1. And then you can draw your V shape. Over here in part me, again, that number, -3, is on the outside of the absolute value. So we're going to go to -3 on the y-axis. And then we're going to still go up 1 over 1, up 1 over 1, up 1 over 1, and then up 1, left 1. And then draw your V. Okay, now on the back, the directions here have us graphing a horizontal translation. So when I graph the horizontal translation, I need to look at my number, and I see that it's on the inside of this absolute value. So what I do is I would start at the positive 1 on the x-axis and draw my graph. So I'm going to ignore this part down here. I'm going to do that first. So go to the opposite, positive 1 on the x-axis, get my vertex, and then go up 1, right 1, and then up 1, left 1. Again, we're making 3 or 4 points. But then down here it says, if the graph of y equals absolute value of x minus 1 is translated 4 units to the right, what would the equation be? So I'm going to use this like pinkish pen here and draw my new one. So 4 units to the right. So here's 1. Go 4 units to the right. 1, 2, 3, 4. I land at the positive 5. Okay. So I land at positive 5. I go ahead and draw my V. And it looks like I'm going to be off the graph just a little bit. Going up 1, right 1, up 1, left 1. Okay. Then I have to write the equation of that. So y equals, I know I have to have that absolute value, and I will always have to have x inside. If this is a positive 5, That's where I'm at. When I put it in here, it's the opposite, so it's a negative 5. Okay. Alright, part B, negative 2. So I'm going to start at positive 2 on the x-axis. Going up 1, right 1, up 1 left, or up 1, right 1 again, and then up 1, left 1. Okay, then it says take that graph and translate it 5 units to the left. So if I go to the left, 1, 2, 3, 4, 5, I land at negative 3. So I go ahead and draw my V shape, up 1, right 1, up 1, left 1. And then my equation, y equals the absolute value of x. Instead of putting negative 3 in, I put the opposite, which is a positive 3.